All right, welcome back. If you are watching this video, it is my hope that you already watched video number 1, where we covered questions 1 through 5. Now we're going to start question 6, and we might be able to get the rest of the review done in this video. I'm going to try and keep this one to under a half an hour as well. So, number 6 is definitely going to have you use different skills from an earlier part of the unit. I believe this is from specifically lessons 8 and 9, and maybe 10 as well. So lessons 8, 9, and 10 were when we started looking at the direction of the left and right arrows. We also looked at the behavior at different x values. So we're going to take a look at a couple things in this problem. Number 1, we have to figure out the direction of the arrows. We have to figure out what crossing points are on the x-axis. And we need to determine if things are going to cross or they are going to bounce at that x-axis. So a couple little things of background knowledge that I think are important for this section. Number 1, we need to be very aware of our directions of our arrows. So if we do an even and an odd and a positive and a negative, we want to remember that the arrows go up, up, and down, down for the even degree functions, and then the odd function will start down, up if it's positive leading coefficient, and it will be up, down if it has a negative leading coefficient. So that's the first piece of background information you need to know for this question. And you also need to know if something has a multiplicity of 1, that will be a cross, and if it has a multiplicity of 2, it will be a bounce. So let's start putting all that together in our problem. Because question A says to sketch a graph of the polynomial. So the first thing I want to do is I want to analyze this factor. And I'm going to look and see, I can probably, I'm just going to do this right here. 2x plus 3 equal to 0. And then I'm going to take x minus 4, and I will set that equal to 0 as well. Now, remember, if there's a 2 here, that means that technically there is another x minus 4. Sorry. There's another x minus 4 equal to 0. But since they create the same x value, we need to remember that this x value is going to have a multiplicity of 2, and this one will bounce. So I don't actually have to do 2 solvings there, but that's how we're going to use that squared to help us understand what the function looks like. So let's back up. We right now are finding the vertical and horizontal intercepts of this function. So right now, the horizontal intercepts, those are the x-intercepts, and the verticals are the y-intercepts. So for these, we're doing the x's right now. Okay, we're doing the x's, so that's the horizontals. We'll subtract 3 from both sides, and then we divide by 2. So x equals negative 1.5 is going to be one of our crossing points. And I'm going to go over to negative 1.5 and make a dot. And then we're going to find the other x value by adding 4 to both sides. And we get x equals 4. And that one is going to have a multiplicity of 2. So we're going to go over to x equals 4, 1, 2, 3, 4, and we're going to make a point there. So the reason I said M2 is because that one had a square on it. And then this one's going to be an M1, or a multiplicity of 1, because there was technically like an invisible little 1 there as a power. So that begins our process of figuring out what the x values are. Now I want to show you how to calculate the y-intercept, or the vertical intercept. So vertical intercepts are going to be whatever the constant of the function was. So I'm going to take the constants of these functions, or these factors, and I'm going to multiply all those. So I'm going to take a plus 3, and I'm going to take that negative 4. But remember, there are 2 negative 4s that would make the constant. So we're going to do negative 4 times negative 4. That would be a 16. And 3 times 16 48. Okay, and that's a positive 48. So what I want to do there is I want to take this point and I'm going to put it right at the top. And we could even label that point 0, 48. That's going to help me understand when the function goes up in that section, how high up to make that go. You'll also notice that I'm not putting y-intercepts, or I'm not putting labels on the y-axis, because right now the only y value that I care about is the y-intercept. So let's start putting all this into motion, basically. So we understand that end behavior is using the degree and the leading coefficient. And so I look back and I see that there are 1, 2, 3 factors. Now you might have saw me underline that twice because that squared shows that that factor happens twice. So I just counted 3 factors and we don't see any negative out front. So this is a positive odd function. And that means that we are in this region right here. So we know that this is going to be a down and an up pattern, but it asks us to use arrow notation. So we're going to tell the reader that I'm going to look at the left side of the function. And when I do that, this arrow goes down. So we're going to say that the function approaches negative infinity. So I think it's very important to know that this negative infinity is meaning left, and this negative infinity is meaning down. And the reason that is because in the first one I'm talking about the x-axis, which goes left to right, and then the f of x is talking about the up and down of the function. So that first one, I'll try and get all these arrows out and make this look cleaner. That is the answer for the left arrow. Okay. The right arrow is going to look very similar with notation. It's going to say x approaches positive infinity, and f of x approaches, let's look and see, this was an up arrow, so we're going to say positive infinity. Okay. So all that just for the arrows. And I know right here that the arrows are down up. So on the left part of the function, I'm going to put a down arrow. And on the right part of the function, I'm going to do an up arrow. So the real question is, how do we figure out how it crosses and goes up and down? And one thing I want to remind you of is that there should be no other crossings because we just found the crossing here and here. So really we need to pay attention to this bounce that's supposed to happen at the red dot at positive 4. So that tells me that this blue one is going to just be a cross through because it's multiplicity of 1. It's headed up to this y-intercept. And then as I come down, I start to think to myself, well, if this crosses through, it will no longer have an up arrow. But the reason I know it doesn't cross through is because the multiplicity is 2. So we're going to see this bounce at the red dot because of a multiplicity of 2, and there was a multiplicity of 1 at the crossing spot. So that is a pretty good version of the function. It has end behavior that is consistent with a down-up pattern, and it's crossing at a blue multiplicity of 1, and it's bouncing at a multiplicity of 2. So that's where we are seeing that all come to fruition, and that is a really good version of number 6. That's a fun one, but it's also a frustrating one if you don't understand how the arrows and the bouncing and the crossing are supposed to match up. So let's try number 7 now. So number 7, the wording cut off on my paper, but this is saying the graph of a polynomial function is shown. So one thing we want to start looking at are the fact that these arrows are up, up. And when they ask us about question 1, degree, well, now we need to draw that box again. And because I have 2 up arrows, I'm really only focused on one of these boxes. So this up, up pattern is even and positive, and this negative leading coefficient would give us a down-down pattern. So we have an up-up pattern. So that means that we are dealing with this right here. So when I'm asked about the degree, is it even or odd, I'm going to say even is the degree because even degree functions have arrows in the same direction. Some would say that this function is just like a boy band because the arrows are going in one direction. Pause your video for laughter. I know that was hysterical. And I'm going to ask people to tell me what the band was that I referenced in this video. And if you write Jonas Brothers on your quiz, I'm going to give you half an extra point because you watched the video. So write the phrase Jonas Brothers somewhere on your quiz, and I will give you half a point. Ooh, I didn't even plan on doing that, but that's fun. So let's see who watches this video. Jonas Brothers. Okay, let's move on. Part B. It asks about the constant term of the polynomial, and we know that that's the same as asking what is the y-intercept. So the fact that 0, 36 is labeled, we're going to say that the constant is 36 because that is equal to the y-intercept. And what that's really telling us is if we wrote the function out in standard form, at the end it would say plus 36. Okay, so that's an important part of that. Now, they're going to ask us to write a function now, and notice they didn't say what form they want the function in. They just create a possible polynomial function. So what that tells me is that we are going to write out factors. And I don't know how many factors there are to write until I look and see how many crossing points are on the polynomial. So let's take a look at the crossings and the bouncing. We see 1, 2, and 3 places that the function either crosses or bounces. So that tells me that we need one more set of parentheses. So let's break these points down a bit. So the first one right here, I see it at -4 and it is crossing. So if the x value is -4, I switch it to become a factor of x plus 4. Now I look at this next function crossing. It's called a horizontal intercept, or it's called a vertical intercept. And that one is crossing at x equals -1. So we will do x plus 1 as the factor. Now last but not least, we see over here at x equals 3, there is a bounce. So technically, there are 2 zeros for that factor. So I'm going to write x minus 3. But because there is a bounce, and I'm going to do that in a different color to show you, there is a bounce occurring here. A bounce makes a power of 2. So altogether, we have f of x equals x plus 4 times x plus 1 times x minus 3, but that x minus 3 is there twice. And if we double check the degree of this function, we can confirm the up-up pattern because we have 1, 2, 3, 4 factors, but only 3 distinct zeros. So that's a difference, and we're going to see a question like that on a page down in the review. But when you see 3 spots of crossing, that means there were 3 distinct zeros, but the degree could also be more because, like in this one, we see a power of 2. So that confirms question number 7, and we're going to move on. Great part about the video is if you want to go back and listen to my explanation, you can listen again. So for number 8, it says for each pair of polynomials given, find all the points of intersections and their on their graphs. So I look at functions g, and that is x plus 6 times x minus 4. So the first thing I'm going to do is I'm going to rewrite that in standard form because I'm going to have to move everything around to get a combined equation. So we're going to write x squared plus 6x minus 4x minus 24. And that's all going to be equal to the other function. And this one is x minus 4 squared. So a really common mistake that people do is they just square the x and they square the negative 4. And that would be x squared minus 16. And that is not how you write x minus 4 squared in standard form. You're forgetting major pieces of that factoring. So I want to show you the box method. I want to show you a strategy to make sure that you get the other terms. If we use x minus 4 and x minus 4, we're going to see that this turns into x squared, this turns into plus 16, and this is going to be minus 4x, and this will be minus 4x. So when I rewrite this, I'm going to write x squared minus 8x plus 16. So I'm going to even erase that part because I don't want you thinking of it like that. I want you to make sure you are using the box method and you're getting 4 terms when you multiply that out. Okay, another common mistake I see is that students tell me negative 4x minus 4x is 0. That is wrong. Okay, negative 4x minus 4x is like when your friend owes you $4 and then your friend asks you for another $4. So altogether, your friend owes you $8, not 0. So that's a common mistake to look out for. Make sure that we're using our combining like terms to get negative 8x right there. Okay. So from here, we're going to combine these equations, and I'm going to use subtraction for this term, and I will add 8x to both sides, and I will subtract away 16 from both sides. So from there, oh dear, hold up, wait a minute. Something I just realized. There's a negative sign. And I'm going to guess that maybe we multiplied that out and forgot to apply the negative sign at the end. So I'm actually catching myself in a mistake. This is good. Let's fix it. So if this negative sign is in front of that, we basically need to make every single part of this negative. Negative, 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 negative. So I'm going to put a negative sign on x squared. I'm changing the minus sign to a plus, and I'm also writing a minus 16. So let's rewrite this. Let's get our ducks in a row here. Okay, x squared plus 2x minus 24. We're going to say equals negative x squared plus 8x and minus 16. Okay, let's check. We got a negative, and the original was a positive. We have a positive, the original was negative, and we have a negative because the original was positive. Okay, now we're ready to start moving terms. Subtract 8x, add 16, so we'll add x squared minus 8x and add 16. So at this point, we are going to have 2x squared minus 6x, and negative 24 plus 16 is negative 8. So here is where we're going to use a strategy of dividing by 2 on every term, because each of those is divisible by 2, and we're going to make our lives easier by factoring out x squared minus 3x minus 4. And when that is equal to 0, we can solve and find the x values. So let's do that over here. I'm going to clean up my space a little bit. And we know that x squared minus 3x minus 4 needs 2 factors. And we need 2 numbers that are going to multiply to negative 4, but add up to negative 3. So that's going to be minus 4 and plus 1. So we have x equals 4 and x equals -1 as our x values. So the answers to this problem are going to be 4 comma something and -1 comma something. Last step here, we're going to plug this back in and find out what the function equals. So when x equals 4. So I'm going to put a 4 in, and I'm going to write 4 plus 6 and 4 minus 4. Now that's going to equal out to 10 times 0, and that means we have 4 comma 0. The other function we can plug in, we get -1 plus 6, and we get -1 minus 4. So we have a +5 and a -5, and I'm getting -25 as the crossing. So those two crossings are 4 comma 0 and -1 comma -5. We can check Desmos in a little bit to go over that. One moment. Okay, so I'm going to create a little more space on this one. And we have been given two new functions, okay? We've been given g of x, and we're told that that is going to cross with h of x. So we need to set those equal to each other. We need to find their crossing points of x's, and then we'll find their y values where they cross. So let's try the first one. This is going to be 3x minus 5 times x plus 1. So we could use a box method to show that. 3x minus 5, and we've got an x plus 1. So 3x squared plus 3x minus 5x minus 5. So that means 3x squared, take away 2x minus 5, will all be equal to 2x minus 1. And I took that from h of x. So from here, I'm going to subtract 2x, and I'll add 1. Subtract 2x, add 1. And make sure that we are getting 3x squared minus 4x minus 4. So this is definitely a trickier problem than the last one, because to find the x values, we need to factor something with a 3x squared. And last time, we divided out a 2 to make it just 1x squared. But down here, notice that this is a 3x, and we're going to need to factor out polynomial. We know it will have a 3x squared. We know it will have a minus 4. But somehow we need to make minus 4x's in this box and this box. So when I start seeing that, I have an understanding that this must be a 3x and this must be an x. And somehow we need to make sure that there's only going to be minus 4 x's altogether. So this is where we need to start using a little bit of our factoring, and this might take a couple box methods where we have to test things out to try and see how to get the factors in the right order. We need to make sure that our constants are multiplying to -4, and that 3x squared is how we are getting our first term. So I'm going to set each of these up the same, and then we can try and play around and get the right amount of x's. So there's a couple ways to make -4. Right? We could do -1 times +4, and in that case we would get plus 4x and minus 3x, and that is going to equal out to positive 1x, which is not, see, positive 1x is not the same as negative 4x, so that did not work. So what I noticed there is that the 3x might be a powerful type of number there, so let's try out 3x plus 1, and let's try 3x minus 4. So this is going to be minus 4x, and this is going to be plus 3x, and That's not getting it for us either. So what we're learning here is that negative 1x, right, not equal to negative 4x, and that's telling me that the 1 and the negative 4 might not be the right path. So now we're going to try and get to 2 times negative 2 and see if that works. So here I have 3x times negative 2, it's negative 6x. And then I have x times positive 2, and that is plus 2x. And ladies and gentlemen, that is going to be the right answer, because negative 6 plus 2x is going to give us negative 4x. So after a little bit of a struggle, we learned that this is actually going to be equal to 3x plus 2 and x minus 2. So from there, we need to start finding our y values. So I'm going to erase the unsuccessful box methods. It did take us 3 different box methods to get to that factoring. But now what we're going to do is we are going to set 3x plus 2 equal to 0, and we're going to set x minus 2 equal to 0. And to get those x values, we are going to solve. X equals negative 2/3, and add 2 to both sides, and we get x equals 2. So, last but not least, we know that negative 2/3 comma something will be one of the values, and we know that 2 comma something will be one of the values. So, I'm going to figure out what those y values are, and I'm going to plug them back into h of x, because this is a much easier function because it's only going to be times 2 and minus 1. So I'm going to put the x value of 2, sorry, that's not f, that's h. So h of 2 equals 2 times 2 minus 1, 4 minus 1 equals 3. So that means that we have 2 comma 3. And then I will try and figure out this y value for, I did f again, whoopsies, h of negative 2/3 equals 2 times negative 2/3 minus 1. Now, this is where I would probably use a calculator if I were you, but we could multiply this and we get negative 4/3 minus 1. And honestly, I would encourage the use of a calculator there. But to do that out correctly, we would do minus 3 over 3, and that would be negative 7/3, or that's negative 2.3 repeating. So negative 7/3. And I will confirm this on Monday, but I do not believe that you will be dealing with any x values that are fractions on your test. You would be more likely to see something like number 8a, not number 8b. Okay, but 8b is definitely the harder of the two of those. So overall, your answers for this question are going to be negative 2/3 comma negative 7/3, and 2 comma 3 are your answers. All right, let's take a look here. Okay, so this is the Desmos active section, and I'm probably going to make a third video for a few of those problems, because I think Desmos is really the way to do that, do those problems. But number 1 and number 2 do not require Desmos. Okay, this first question is asking which of the following could be an equation of the graph. So this one right here is at x equals negative 4. So we are expecting to see an x plus 4. This one is going through 0, so we're expecting there to be an x a part of that. And then this is bouncing at x equals 3, so I'm expecting to see an x minus 3 somewhere. Now, if you look at these options, notice that all of them have a multiplier of negative 1/5. And based on the graph, that just means that this was shrunken by a fifth, right? A factor of 1 over 5. But none of those are different in the multiple choice options. So in your brain, you have to ignore the negative 1/5 and really pay attention to, all right, all these had an x, so that's not going to be the difference maker. We know that x minus 3 needs to be in there.